In this video, we'll complete our discussion about simple T procedures, talking about robustness of the T procedures. And if we think about the word robust, in reality, it means something that's strong, it's something that's sturdy. With respect to methods, mathematical methods, what this means is that a small change in the data will not destroy the reliability of the method, okay? And for our T procedures, what that means is a change in the data or some sort of violation in the conditions does not give us results that we cannot trust, okay? So let's talk about the meaning of robustness in more detail. So we know that the T procedures are exactly correct when the population distribution is exactly normal. Great. Apparently we love it when things are normal. So if the population distribution is strongly skewed, and I think strongly skewed means something like this, right? Then the T procedures are not robust. Okay, this is going back to the condition that we need something that's roughly symmetric. Since X bar and S are sensitive to outliers, the T distribution is not robust against outliers. What that means is if we have an outlier in our data, extreme outliers, little outliers, it doesn't matter, then we can't trust the results of our T distribution. And what this really emphasizes is that we need to explore the data, which was the first unit of this class, explore the data prior to using our methods. And that's always true. It doesn't matter which methods we end up using. Alright, so there's sort of a rule of thumb for with respect to sample size and skewedness and outliers. So when n is less than 15, so when our sample is tiny, we can use the T procedures only if our data is close to normal. Remember, when the sample size is very small, there's higher chance variation. So only if close to normal. Alright, so if n is greater than or equal to 15, we can use the T procedures when outliers, except when there are outliers or strong skewness. Right, and when our sample size is greater than or equal to 40, our T procedures can be used even for skewed distributions. Okay, I think that you might remove the outliers. Skewed distributions aren't too bad because remember that our T procedures rely on the distribution of our statistic, okay? And that's important because if we take a large enough n, that distribution will approach normal, as we talked about earlier. But here, what we're talking about is the distribution of our variable, okay? So distribution of our variable. And so it does have some influence, especially when our sample size is relatively small. But when our sample size is larger, what this is saying when it's saying that T procedures can be used even for skewed distributions. What this is saying is when your sample size is large, then it doesn't matter what your variable distribution looks like. Your sampling distribution, because a t-distribution is a sampling distribution, your sampling distribution does approach normal if we're relying on theory. So in summary, basically this video goes over robustness, and you should go ahead and spend some time trying to understand what this means. Hopefully this video helped.
My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. We live in a world of technology. They're collecting information on your humanity. Social networks, gaming, and in-home software.
Hello, Alexa.
Statistics helps us be more aware. Haters gonna hate my spicy lyrics. Why you gotta be so mean? Pulling me towards your extreme moods, but the median never fails to center me. 50 to my left, 50 to my right. Got these correlation and regression tools, forget them fools. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. The mean of the means is the mean. The mean of the means is the mean. The mean of the means is the mean is the mean of the means is the mean is the mean. Be careful not to fall in love. Statistical seduction from above. Your shape so beautifully symmetric to the eye with a single peak so high. I hypothesize and can testify that your p-value is the smallest I've seen. Mix that with a large power and I reach ecstasy. Your residuals defy the rest. A small scale randomized pattern tells me you are the best fit. My name is Llama, and I'm here to teach you stats, skilling you up with the cold hard facts. My confidence is so high, 95%. My margin of error so narrow, 110. Can you feel me? Can you feel me? I estimate your population parameter based on only one sampling. Oh, haven't the frequentists told you about me? We live in a world of data, attempting to understand life by statistical strife. The implicit bias of cops, success rate of them jocks, medical advances, and AI romances. Statistics.